In this video, we're going to look at 10.5, apply other angle relationships in circles. And it's all about intersecting lines and circles. So this whole set of notes is going to revolve around these first three pictures that we are going to draw and how lines can intersect and behave with the circle. So I'm going to start the notes with these three examples, and I will end the notes with these three examples. So the first thing I need for you to realize is that there's three situations that can happen with intersecting lines within a circle. So if I draw this line here, and then I draw a line that goes through that, and it intersects, I need you to notice where the intersection happened, right here. And that is on the circle. On the circle. Okay? So now, as we move to the next thing, what else can happen with lines and circles? So I'm going to draw a line here and a line here. Where did the intersection happen? It happened right here, and that is going to be inside the circle. Inside the circle. And then last, what else can happen with lines? If I draw a line out here, and I draw a line here, where did that intersection happen? It happened outside the circle. Now that we have looked at all three cases, okay, we have on the circle, inside the circle, and outside the circle, we have angle relationships going on with angles and arcs. So the rest of the notes is going to be looking at the theorems that supports what's going on within the circle. So the first two we're going to look at, we are going to look at the on the circle and inside the circle theorems. So theorem 1011 states, if a tangent and a chord, so now let's look at this over here. This is a tangent and this is a chord, intersect at a point on the circle, then the measure of each angle formed, so look here, angle 1 and angle 2, that is going to be half the measure of its intercepted arc. Now this one we've actually kind of already done, because if you will look back up here, we had an inscribed angle and an intercepted arc. So here's angle 1. Remember, we look opposite, and 1 was half of that. That's basically what's going on here. So if I have 1, let's focus on 1 first. The measure of angle 1 is going to be 1/2 the measure of arc AB. So if this was 50 degrees, then angle 1 would be 25 degrees. Now the measure of angle 2, it is intercepting a major arc. So the measure of angle 2 is going to be 1/2 the measure of arc BCA. Or we could say ACB. So this behaves like the one we've studied before. It's simply 1/2 because it is on the circle. Now, moving on to theorem 10.12, this is the angles inside the circle theorem. It says if two chords, please look at the picture here. Here is AC, that is a chord, and BD, that is also a chord. And they are intersecting inside the circle. So it says the measure of each angle, we're talking about 1 and 2, is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So the first thing we're going to focus on here is angle 1. So here is angle 1. It is saying that it is the sum of DC and the vertical angle, look back here, they're across from each other, AB. So angle 1 is going to be half those two arcs added up. So it's going to be the measure of arc DC added to the measure of arc B or AB, and you're going to add them up and take half of it. Now, I like to remember this one simply by an average. You average the arcs, and the arcs must be across from each other. Now, looking at angle 2 is going to be here. This is BC and AD. So angle 2 is going to be adding up arc AD and arc BC. So you average and you take half. Now, let's look at some examples of all of these two theorems going on. So the first thing I want you to notice, I want you to look at all 5 problems. I need you to notice the intersection of the lines. On the circle, inside the circle, inside the circle, inside the circle. So the 2 that are on the circle, that is going to be theorem 1011, where you take half, only half, of the intercepted arc. So if I am looking at angle 1, it is intercepting this arc, which is 132 degrees. So the measure of angle 1 is 1/2 of 132 degrees. So the measure of angle 1 is going to be 66 degrees. Moving on to number 2, this one says find the measure of arc EFD. So EFD, this is the arc EFD. Now you can see 110 is the angle, so that is going to be 1/2 of this arc. So for this one we would double the arc. So the measure of the arc EFD is going to be 220 degrees. Now that is on the circle. So those are typically the easier ones because it's just acting like an intercepted arc with an inscribed angle. Now 3, 4, and 5, we must think about averaging the arcs. So it says find the value of x. Now I need you to notice that x is here. So this is the arc and this is the arc, the one opposite of it. We need to average the arcs to find the value of x. So the way that you would set this up, you would say x equals, because x is the angle, 1/2 of the arcs added together. So you average 1/2 of the arcs added together. So 112 and 140 is 252. Take half of that and you will get 126 degrees. Now, question 4, a little bit more algebra comes in here. This time it's asking us to find t, and 8t is representing the angle. So again, this is the arcs that 8t is dealing with. You have to be together like vertical angles. So again, the setup is going to be 8t, which is the angle, equals 1/2 of the arcs added together. So a lot more algebra comes in on this one, but it is okay. I am going to use order of operations. I am going to clean up the parentheses in the middle. 3t and 15t will be 18t. Positive 2 and negative 14 will be negative 12. Now you can distribute the 1/2 if you want to, or you can multiply 1/2 to 8t. It does not matter what you do here. I will just use the distributive property. So I will get 9t subtract 6. Bring that 9t over, and I get negative t equals negative 6. So t equals 6. Okay? So finally, number 5, where is the intersection happening? Inside. Therefore, I add and take half. Now this one says find the value of y, and we have to be super careful here. Y is dealing with these right here. Now this one is different because y is now the arc. And we really don't need 102. We need to know the angle that's opposite of y95, the one that's in the middle. So what we're going to do is we're going to take 180 and subtract 102 because those are forming a linear pair, and we're going to get 78 degrees. Now 78 is right there. So now this is the way we set it up. 78 equals 1/2 of the arcs added together. So you can see the y now moves inside to the other side. Now this time I am not going to distribute the 1/2. I'm going to multiply 2 by both sides, and I'm going to get rid of that fraction. That will actually make life a little bit easier as we move forward. So 2 times 78 is 156, and that equals y plus 95. Simply subtract 95 from the other side, and we're going to get 61 degrees equals y. So, as we wrap this first page up, okay, on the circle, you do half. Inside the circle, you average the arcs. And remember, it's the arcs that are opposite. So this arc and this arc added up will give you these angles here.